where clause. So the where clause allows you to provide a list of predicates, right, and combine them using Boolean algebra, right, where you can have all sorts of operators that allow you to compare, right, the left and right value of those Boolean expressions. Yes, whether it's equal, not equal. Notice that not equal is less than and greater than, not the bang equal. Right, and also notice that the equal is a single equal. It's not an assignment, so it's not double equal, not triple equal. It's just simple equal. Then you have keywords such as between, like, and in. So let's take a look at examples. Here's where, using where for retrieving folks that are in Lowell. So we can say where city is equal to Lowell. Notice the single quote, right? Not double quotes, a single quote. You can join several predicates using Boolean operators such as and, or, not. Right, so you have here that first name equals Bob, and last name is Bob, or Bob and Dan. So we have those two records that meet that criteria. You can combine them. You can combine the ands and ors using parentheses, right, to do fairly complex Boolean expressions. Notice again that these are comparing things that are not primary key and foreign key, right? We're using just non-key comparisons. Right. So I mentioned earlier, right? If you have multiple joins, it can become fairly awkward to write. So you can combine attributes that are not relational, right? Like the graduation year, right? And combine them with join operators, right? So here you would replace these two joins where we have the student that joins the enrollment and then joins again with the section. You can combine that into a single from clause, and then the where that has using the and operator that joins first the student with the section and then with the enrollment, right? And combine it with non-relational key properties, right? Where it's some of the predicates are relational, right? Sections and enrollment and students. So all these are relational. The ones in red, right? And then the non-relational here are in blue, right? And you can combine them together. You can also know the keywords between, right? Allows you to retrieve values that are between two ranges. Yes. So when you're doing explicit joins, yeah, the syntax of the join is usually preferable as when you're going to actually implement them. Yeah, so it does some optimization, some parsing when you're doing the plan. Oftentimes, some of those optimizations take those properties into account for optimization purposes. You could ordering where the where clause occurs, you could have somewhat the same optimizations, right? For instance, putting first the relational predicates first before putting any of the non-predicate relations. You could have similar, but in general, the databases will do a lot of optimizations when they have explicit join clauses. Yeah. So between allows you to do pattern matching between values. So and the between can be either strings or it could be numbers. If it's a string, right, it uses the alphabetical order, right, to do a keyword comparison. You could use the not, right, to refer to things that do not match, right, that or not where that Boolean expression is false, right. The in keyword allows you to have a value, right, and be compared against an array of possible values, right. So where you might say, students that are enrolled in the following sections, right, and the section ID could be in there, right. So that value you iterate over the value to see if any one of those values matches the outer value. If it's true, then that record is retrieved. So an example, right, one last name that is in either Boone and Garcia. So it iterates over these. So this could be expensive, right? Because for every record that you're comparing, right, it's going to iterate over that list. Whenever it matches the first one, it stops. Right? It doesn't finish the entire list. It shortcuts it. Like it also I mentioned earlier, allows you to pattern match on strings. Careful with doing like with very short strings that could be very, very expensive. You know, your string comparison should be as large as possible, right? To improve performance. Current user allows you to do queries based on the current user, right? So that I can retrieve my students, my enrollments, my sections of who currently logged in. I'll see my students. If you log in, you see your students. All right, so let's take a look at a couple of SQL constraints.